All right, let's just jump straight into it. In this explainer, we're taking a standard, bare-bones .NET API and completely transforming it. We're going to evolve it into a robust, containerized, and highly optimized piece of architecture. So, you might be wondering, what does it actually take to build a .NET API in 2025 that can handle real, heavy-duty traffic? Well, instead of just staring at a massive wall of code today, we're going on a builder's journey together. We'll start totally from scratch and progressively stack on some really powerful layers to solve real-world performance bottlenecks as they naturally pop up.
Okay, step 1, building the foundation.
To lay that groundwork, we've got to set up a clean architecture ASP.NET Core API. First things first, we define our Postgres connection string right there in the app settings file. Next up, we install the NPGs Entity Framework Core package. Think of that as our direct bridge over to Postgres. Finally, we applied our migrations to generate the database. And just like that, we're off the ground.
But, to keep our codebase maintainable as it inevitably scales up, we really lean into clean architecture. It's all about separating our concerns. So the controllers pass requests down to the services. Then those services handle the heavy lifting, the business logic, transforming our raw entity models into data transfer objects. Those are basically just lightweight, secure little packages of data that are perfectly tailored for the user. After that, the repositories step in to actually hit the database. This whole setup keeps our code beautifully decoupled and, most importantly, super easy to test.
Now, that brings us to a really burning question. How do we easily run all of this stuff? Sure, a local database installation is perfectly fine for a quick dev test, but if we want to truly scale, collaborate with the team, and deploy reliably, well, we need a much better way to manage our infrastructure. Which brings us to section 2, containerizing with Docker.
To orchestrate all these external services, we're bringing in Docker Compose. This is a real game changer because it replaces those messy, fragile local installations with clean, perfectly repeatable container images. Basically, Docker Compose is an orchestration tool that lets you configure your .NET API and your database to run together simultaneously, all from just one single YAML file. You run one command, and your entire environment spins right up. It's awesome. Now, when you're setting up that Postgres container, you'll naturally expose ports and set up your passwords. But listen, the absolute most crucial step here is volume mapping. I can't stress this enough. Without creating a volume to persist your data, your database records would literally vanish into thin air every single time the container shuts down. No way. We want that. Volumes safely anchor the container's data right to your local machine. Moving right along to section 3, caching for speed. So our infrastructure is humming along nicely, but then boom, we hit our first major performance roadblock, repeated, incredibly expensive trips to the database for the exact same data. We fix this by implementing what's called the cache aside pattern using Redis. It's pretty straightforward. Every time we need data, we check our lightning-fast Redis cache first. If it's there, instant return. If it's not, we ask Postgres, and then, crucially, we save it back to the cache for the very next user. There's an old joke that there are only two hard things in computer science, naming things and cache invalidation. And this quote from Milan Jovanovic really hits the nail on the head. We have to make sure to clear the cache value when we are running destructive operations. If you update a price or delete a record in your database, but you forget to clear Redis, your users are going to see stale, incorrect data. Invalidation is absolutely everything here. Next up, section 4, the performance showdown between EF Core and Dapper. As our app grows, we suddenly need raw data access speed, which brings us to a really fun showdown. Think of Entity Framework Core as a luxury sedan. It is packed with super comfortable features, things like change tracking and automatic migrations. It makes you incredibly productive. Dapper, on the other hand, that is a bare-bones Formula 1 engine. It forces you to know raw SQL, but because it has such low abstraction, the speed it offers is practically unmatched. And seriously, the difference in speed is staggering. Independent benchmarks show that Dapper can be approximately 65 times faster than EF Core in specific insert operations. Let me repeat that, 65 times faster. When you're processing thousands of records a second, a multiplier like that completely changes the game. But it's not just about raw speed. The efficiency gains are huge too. If we look at memory consumption for a single insert, Dapper operates much more efficiently, using just 18.23 kilobytes compared to EF Core's 39.09. Dapper just completely skips all those heavy internal mechanisms and state tracking that EF Core relies on. And what that means for you is that your server's memory is freed up to do actual, useful processing. So, are you forced to pick just one of these tools? Absolutely not. Experienced developers heavily recommend a hybrid approach here. You use EF Core for your standard CRUD endpoints, create, read, update, delete, where developer productivity and complex modeling really shine. Then you surgically injected Dapper exactly where you have massive bulk operations or intense performance-critical bottlenecks. It's truly the best of both worlds. All right, Section 5, Mastering Advanced NpGPL Features.
Shifting gears to some specialized superpowers, PostgreSQL has absolutely incredible native JSON support. NpgsqL actually allows you to query these JSON columns directly using C#'s native link syntax. That's language-integrated querying for those who might not know. And if you're doing this, using the newer EF10+ complex types approach with the toJSON method is highly recommended over the old deprecated legacy mapping. It basically lets Entity Framework fully understand your JSON structure so you can do some seriously rich querying. And setting up your security is remarkably painless too. Let's say you want to use the built-in ASP.NET Core identity provider for user authentication. It is incredibly simple to point that at PostgreSQL instead of the default SQL Server. You literally just swap out use SQL Server with use NPGP in your startup configuration before you run your migrations, and boom, you're entirely done. Finally, Section 6, the ultimate architecture. Well, our builder's journey is complete. We have covered a vast amount of ground in this explainer. By progressively adding these layers to solve our problems, we've taken a basic tutorial app and transformed it into a seriously scalable real-world backend architecture. We've got our clean foundation, our Docker orchestration, Redis for lightning-fast reads, that awesome hybrid Dapper and EF Core setup, and some really advanced JSON support. And as this quote from Saeed Gaderi beautifully reminds us, true architectural mastery isn't about stubbornly locking yourself into one single perfect tool. It's really about combining the right tools, whether that's Docker, Redis, EF Core, or Dapper, to fit the exact specific requirements of whatever project you're working on. So now that you've got a deep understanding of how a highly scalable system evolves and how all these individual puzzle pieces fit together, what choices are you going to make when you start your next big project? Keep these architectural layers in your back pocket and happy building.